Hello, students. You are welcome to today's class. We are considering a topic titled Differential Equation with the application or use of separation of variables. We will be treating several questions that involve separation of variables, but we want to see the one that involve tan x. Y tan x placed close to dy over dx. What you need to do, we are going to remove tan x from this place on the left hand side, and we're going to see how it can be taken to the right hand side. And see that in the right hand side we have 4 plus y squared sec squared x. Okay, now let's start. Y tan x dy over dx equals 4 plus y squared sec squared x. You can see that tan x is having expression of x. If you go to the right hand side and 4 plus y squared come to the left hand side, let's just say divide both sides by 4 plus y squared. First, you can divide both sides. You can start by saying divide both sides by tan x. I want to start my own with divide both sides by 4 plus y squared. Now y tan x dy over dx divided by 4 plus y squared equals 4 plus y squared sec squared x divided by 4 plus y squared. It cancel out. Now y tan x dy dy over dx divided by 4 plus y squared equals sec squared x. Now you can see that what is odd here is tan x and dx. And say divide both sides by tan x. When you do that, we're having y, we're having y tan x divided by tan x, open bracket 4 plus y squared dy over dx equals sec squared x over tan x. This tan x cancel tan x. We're left with y over 4 plus y squared dy over dx equals sec squared x over tan x. You can see that dx is still hot. Dx will leave the left hand side and move to the right hand side. Now say multiply both sides by dx. Now y over 4 plus y squared dy over dx multiply by dx equals to sec squared x over tan x dx. Try to multiply both sides by dx cancel dx. We're left with y over 4 plus y squared dy equals sec squared x over tan x dx. Now we'll carry out separation of variables. You can see 4 over, so you can see y over 4 plus y squared dy equals sec squared x over tan x dx. Okay, you can see your carry out separation of variables. Similar expression has been put where it needs to be. Now you can now integrate both sides. Now integral of y over 4 plus y squared dy equals integral of sec squared x over tan x dx. At this point, when you differentiate 4, you have a 0. When you differentiate y squared, you have 2y. You have y here at the numerator. What you need to do is to add 1 over 2. When you have 1 over 2 like this, and we differentiate 2y, which will give you, sorry, when you differentiate y squared, it will give you 2y. It will now cancel out to give you your y. That means that you have to introduce half. When you write ln of 4 plus y squared, you give it the integral of y over 4 plus y squared. Okay? What I'm saying again is that when you differentiate a constant, you have a 0. When you differentiate y squared, you have 2y. And when you check the numerator, it's different from what you have. You have y at the numerator, but you have 2y when you carry out differentiation of y squared. What you need to do to be able to balance everything, balance the differentiation, is to add half, so that 2 will cancel this to give you your y. Okay, you now have the expression to be integral of y over 4 plus y squared will now be half ln 4 plus y squared. This half is to take care of this squared, y squared. Now, when you come to this other side, the ln of tan x will give you integral of sec squared x over tan x equals to ln of tan x plus constants. Now, I want you to know that when you differentiate tan x, you will have sec squared x. You must always take note that the differentiation of the denominator must give you the numerator, so that you know that what you are looking for, the lane you are taking, is correct with the integral of sec squared x over tan x. And let me show you how the differentiation of tan x will give you sec squared x. Because when you have y equals to tan x is equals to sine x over cos x. And we apply this formula, quotient rule, y equals to u over v, dy over dx equals v, keep this v, differentiate du over dx minus u dv over dx over v squared. And I want to do the same thing for this expression to see that we are going to get sec squared x. Now dy over dx equals, you keep this cos, is your v, u over v, as cos x, d of dx of sine x minus, what's your u, sine x, d of dx, what's your v, cos x, everything over what's our v, cos x, that's cos squared x. And so because v is being squared, cos squared x, because cos x, when you differentiate sign, we're having cos x minus sine x. When you differentiate cos, you're having multiply by minus sine x. Differentiation of cos will give you negative sine x, and differentiation of sine will give you cos, no negative, over cos squared x, which is cos x times cos x, that's cos squared x, minus sine x times minus sine x, that's plus sine squared x, over cos squared x. The standard is cos squared x plus sine squared x is 1 over cos squared x. Don't forget, when you have your sukatua, having another one, chosa cow, you can see that this cos squared, this so this cos, this tan, this cosecant, this secant, and this cotangent. This we are squaring the cos, that secant is being squared. We have 1 over this cos will give us seconds. But since you have 1 over cos squared x, means that we are squaring the cos. Okay, having like 1 over cos will give us seconds. 1 over sine will give us cosecant. 1 over cos will give us secant. 1 over tan will give us cotangent. And since you're having cos squared x, you're going to square this sec squared x also. That's why it will now be equals sec squared x. That means that when you differentiate tan, x must have sec squared x. You can now say the lane of tan x is integral of sec squared x over tan x. Okay. I just do this so that you can understand that when you differentiate the denominator, you have the numerator. You will now be sure that your lane, you are taking the right lane. Okay, lane of tan x will give us integral of sec squared x over tan x. But you can confirm it by differentiating the denominator to give you the numerator. Now you now multiply through by 2 so that this half can cancel out. Now 2 times 1 over 2 lane 4 plus y squared equals to 2 lane tan x plus c. You don't need to multiply the constant by 2 because the constant, not necessary. 2 cancel 2. Left with lane 4 plus y squared equals to lane of tan squared x. These two will now come to the front plus c. Okay, now let's our c. Let's our c where our c equals to lane c. Now lane 4 plus y squared equals to lane of tan squared x plus lane c. Okay, now since in indices, when you are using lane to represent the two expressions, you change addition to multiplication. You're having lane of 4 plus y squared equals to uh, lane c tan squared x. Okay, now lane cancel lane. Now have 4 plus y squared equal to c tan squared x. This is the end of our class. Thanks for listening. Please don't forget to drop your question in the comment section. Have a wonderful day.